Hello, my students. We are in lesson 22. I still have a little bit of a rough throat from my cold that I just got over, so please excuse that. But we are going to talk about uniform motion problems today. Yay! If you remember from last year, that was about 3/4 of the way through Algebra 1. So that means we are about 3/4 of the way through our review lessons. So we have about, I'd say, 5 or 6 more, and then we'll get into some new material in Algebra 2. So let's begin with 22.1. And let's, first, before we start into that, remember when we talk about uniform motion and distance problems, DIRT. Distance equals rate times time. So that means that if distance 1 equals distance 2, then the rate of 1 times the time of 1 equals the rate of 2 times the time of 2. Okay, remember our subscripted variables that we used? All right, so put this in your notes to refresh your memory. Okay. And then I'm going to jump right into problem 22.1. All right, and this problem is a doozy, so I'm going to type that in for you. All right, here's our problem that we need to solve. Roger made the trip on Sunday, and Judy made the same trip on Monday. Roger traveled at 12 miles per hour. Judy traveled at, is that right? Yeah, Judy traveled at 20 miles per hour. So her time was 2 hours less than Roger's time. How far did they travel? So let's begin by looking at our illustration. Remember those illustrations? They both start at the same place, right? And the distance that Roger traveled was the same as the distance that Judy traveled. The distance of Roger equals the distance of Judy, right? They went to the same place, so dr equals dj, right? d1 equals d2, dr, so the distance is the same. So we can say that the rate of Roger times the time of Roger is equal to the rate of Judy times the time of Judy. And now we can create our table that will tell us this information so we can solve the problem. So we have the rate and we have the time for Roger and Judy. So let's fill that information in, right? Here's our table. So Roger traveled at 12 miles per hour. That's his rate. His rate is 12. Roger's rate is 12. Judy traveled at 20 miles per hour. So Judy's rate is 20. This should have said so her, but autocorrect. I don't know what that means. So her time was 2 hours less than Roger's. So Judy's time is going to be, so let's take the time of Roger. We don't know what that is. We know that Judy's time is 2 hours less. So we're going to subtract 2. Okay? So that's the information that we need in order to fill in here. So we just take this and drop it in. So RR, that's going to be 12. TR, we don't know what TR is, so we just drop that variable in place. Now the rate of Judy is 20, and the time of Judy is TR minus 2. See how that works out? We take this and put it in here. So now we just do the math. So let's distribute here first. So 12 TR is going to equal 20 TR minus 40. Right? Because 20 miles per hour times 2 hours is going to be 40 miles. So now we just change sides and change signs. So let's bring 12 over here, or let's bring 20 over here so we don't have to do this twice. So that's going to be a negative 20 when we change signs. So that's going to be positive 12 and negative 20. It's going to be a negative 8 TR equals negative 40. So when we divide, TR is going to be equal to 5. So now we know how far they traveled because distance is rate times time. So if this is equal to 5, we can say 12 times 5 is the distance. So that's going to be 60 miles. Because RR times TR is equal to the distance of R, right here, right? DR equals R times T, dirt, that goes back to here. Our dirt, we're traveling across the dirt, across the earth. So when we substitute 12 and we substitute in 5, we get 60. So that's 60 miles. That is the answer that we're looking for. Okay, so you can see how making your chart and making your illustration helps you with uniform motion problems. It helps you to visualize remembering the formula, helps you to create the proper number sentence with the right variables. Using your table helps you create those right variables and helps you drop those values in for each pair of variables that you're using, or each subscripted variable that you're using. And then that helps you find the problem's answer. All right, so don't be afraid to use your illustration to set up your tables, to pull the information out as you need to. Okay, let's try another one. Let's do example 2.2. I'm going to clear this page. And 22.2, I'm going to type that in for you just a moment. All right, so here's our problem that we're given. Brer Rabbit, or Briar Rabbit, hopped off toward the briar patch at 10 kilometers per hour at 10 a.m. All right, so here's our line. This is 10 a.m. This is the starting time and the starting point. Okay, at noon, so this is Brer Rabbit. This is the rabbit. At noon, so it's right in here, that's 12 p.m. The wolf started and caught him, so they were at the same point, right? Because he caught him, so he had to be in the same place. He caught him at 2 p.m. So at noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how fast did he run? Actually, I think I did that a little bit incorrectly. It's the same starting point, but for him, it is 12 p.m. So I'm going to move this over here. All right, there's my illustration. So he started at 10 a.m. and traveled this distance. Oops, I need my pen. This distance of the rabbit equals the distance of the wolf. It's the same distance, okay? But he started at 10 and he started at 12, so 2 hours later. And at 2, they were at the same place at the same time. Okay, so their distance was the same. That's what this illustrates. That's why I had to change that. So we know that dr, the distance of the rabbit, equals the distance of the wolf, which means that the rate of the rabbit times the time of the rabbit is going to equal the rate of the wolf times the time of the wolf. Okay, so there's our initial formula. So now we need to make our little chart. So we have the rabbit and the wolf, and we have the rate, and we have the time. So let's look at this. We know that the distance covered by the rabbit took him 4 hours. From 10 a.m. to 2 p.m. is 4 hours. So the time is 4 for the rabbit. And we know the wolf started at 12 and was the same place at 2. So it only took him 2 hours. Okay? So that's good. We understand that. And we also have the rate of Briar Rabbit. We are told that Briar Rabbit was moving at 10 kilometers per hour. So the rate of the rabbit is 10. What we don't know is the rate of the wolf. That's the unknown. So we can start subbing in here. The rate of the rabbit is 10. The time of the rabbit is 4. The rate of the wolf we don't know. And the time of the wolf is 2. So that's going to be 40 equals 2 times RW. We divide both sides by 2. So that means that 20 is the rate of the wolf. So he was running 20 kilometers an hour, which makes sense because in half of the time he got to the same place. So he had to be moving twice as fast. And so if the rabbit was moving at 10 kilometers an hour, the wolf was moving at 20, then that adds up because 10 times 4 is 40 and 20 times 2 is 40. So that makes perfect sense. So you can see how to make your chart again, use the information you're given. Making that illustration helps you to visualize it. And then you can solve your problem. All right. I hope that refreshes your memory on uniform motion problems where the distance is the same. That is the key. The distance is the same. If the distance is the same, then this works. Okay? All right. Because the distance the rabbit and the distance the wolf are the same, this is the same. This can all be done pretty easily. So let's move on to part B, which is similar triangles and proportions. So again, we're going to be working with some scale factors here. So we are given in 22 point, oh, do we even have a problem? We don't have a problem. We're just given an example. So we have an example here, but it's not a problem. We have a triangle. Let me draw that for you. Okay, and I'm going to copy it because it is similar. All I have to do is copy and paste. And this time, this triangle is a little bit bigger. I don't need to rotate it any. It just needs to be a little bit bigger. All right, so we have two triangles here. And in this triangle, this is 5, but this angle of measure is congruent to this angle of measure. And this angle of measure is congruent to this angle of measure, right? So this is 7, this is 8. We don't know what this is, we don't know what this is, but this is 9. So, by default, we understand because of the rule of triangles and measures, the inside measure being 180, if these two are the same in both of these, then the angle of measure for the remaining is going to be the same in each triangle, right? So these two are going to be congruent. They're going to be the same angle of measure. So now we know we have two similar triangles, so we can use a scale factor in order to find the length of the sides. And so the way we find the scale factor is we look at which one has all the measurements, and this one has all the measurements. So this is the one that we are going to use to represent our scale factor, or to create our scale factor. So we are going to say 5 times some scale factor is equal to 9. Actually, I'm sorry, that's the wrong number, because that's not the congruent side, is it? This is the congruent side, because we have the 2 and the 3 here, the 2 and the 3 here. I just made a goof, sorry. So it's 7 times some scale factor equals 9, right? So that means that our scale factor is going to be 9 over 7, because we divided both sides by 7. That's what that's going to be. So in order to find x, all we have to do is multiply 5 times our scale factor. So 5 times 9 over 7 equals x, because 5 and x are the congruent sides. And the same thing for y. We take the congruent side, that's 8, we multiply it times 9 over 7, and that's going to give us y right here, because those are the congruent sides, because you have 1 and 3 here and 1 and 3 here. Okay, so now we just have to do the math. So we put this over 1 to make it a fraction, to make it easier to do. And I'm going to pull out my handy dandy calculator. And I know that 5 times 9 is 45. So 45 over 7 is equal to x. And if you wanted to do the math, you could say that that's going to be 45 divided by 7 is 6 with a remainder of 3. So x is going to be 6 and 3/7 of whatever unit of measure that is. And y, 8 times 9 is 72. Yes, 72 over 7. And we know that that's going to be 10 with 2 over 7 left. So 10 and 2/7 of whatever unit of measure this is our answer. Okay, so we have, that's pretty easy to figure out and to find the answer for. And that's all we're doing. You just find the one that has all the measurements, and then you set that one as equal to your, or as multiplied by your scale factor, to get the one that you don't have the measurements for, but is congruent to. All right, very good. That is all we have for lesson 22. I will see you in lesson 23.